Hello and welcome. My name is Matthew Purse, Systems Engineer for Siemens Motion Control. In this video tip and trick, I would like to go over how we can use Profinet IRT to tie together two Simotion controllers. This can be a great solution for when two Simotion controlled machines are built independently, yet they still need to work together as one integrated system. One benefit to this method is that you can link together two machines without the need for rebuilding your project, sharing your project code, or using a shaft encoder to communicate access positions. What you'll need are two Simotion controllers with Profinet interfaces. If your Simotion controller lacks a Profinet interface, you'll need to install a CBE30 card into the option slot. In this example, we will be using two demo units to demonstrate this technology. Currently, these demos are running their own routines and are completely independent from each other. However, when we give the command, we can now see that the left machine follows the right machine as if this were controlled by one Simotion instead of two. So with that, let's go ahead and jump into Scout to see how we do this. So on my PC, I have two projects open. This project is for my first machine, and this project would be for my second machine. I will declare the second machine as my master because I'm going to want to receive access positions from that machine to control the access positions of this machine. Both projects are set up similarly. We have one controller and then two real axes and one virtual axis. The main difference is in the routine. On the slave side, it's just a simple gearing program, and on the master side, it's a simple camming program, or it will follow a sine wave cam profile. The slave program works by enabling our axes, and then we'll have a bit up here that will decide whether we want to be in local mode, where we're just simply gearing onto the local virtual master and giving it a speed set point, or we can have it gear onto a axis on the master machine, and we'll add the code for that in a little bit. So to set up our project for Profinet IRT, we'll have to go into the hardware config, but I'll go ahead and close out my master program because we don't need it for now. Okay, now let's open up the hardware config for this device. Since this Simotion controller will be the slave controller, we'll just need to set it up to be an iDevice. But there are three things that we want to have unique between device A and device B. This is going to include the controller name, the Profinet interface name, and the Profinet interface IP address. To change the controller name, we'll go up here and we'll right click and go to Object Properties. Currently, I have it set up as D425_slave. On the master project, I have it set up as D425_master. Since both are unique, I can go on to the next step, which would be to choose my Profinet interface. Here we're using two 425-2 motion controllers, and each of those have two Profinet interfaces, one at X50 and the other at X127. I will use the X150 Profinet interface, so to configure that, we right click and go to Object Properties. The first thing we want to do is make sure this has a unique device name, so I'm going to append a -slave to this, and a unique IP address. Right now the IP address is set as the default, so I'll keep this where it is, but on the master side I need to remember to change it. Next we'll go to the Profinet tab, and we'll change the send clock, and I'll put it at 4 milliseconds since that should be plenty for this application. And then we'll go to the iDevice tab. Because this will be an iDevice, we check that box. That enables the next box, which we check to enable the third box, operate the complete iDevice in isochronous mode. And now the only thing left here is to set up our byte map. So the idea is that we want to send axis positions from one machine to another. So we're going to send the entire motion profile, which includes the position, the velocity, and the acceleration. Those three things will equal 24 bytes in this case. So we'll go ahead and we'll start this byte. We'll start it at, how about 350? So it starts at byte number 350, and we'll give it a length of 24 bytes. And then we hit OK. And we'll do the same thing on the output side. We'll start it at 350 and give it a length of 24 bytes. So now we'll hit OK. And we'll want to make sure that our Synamics integrated is also configured for a 4 millisecond cycle time. So we right click, go to Object Properties, click on Isochronous Operation, and ensure that we are at 4 milliseconds. We'll hit OK. And as a final thing, we will go to our Profinet interface and say Insert Profinet IO System, so it knows to expect a device will be connected to this Profinet interface. Once we're done, we'll hit Save and Compile. Then we'll go to Options and then say Create GSD file for iDevice. What this will do is it will encapsulate our hardware config and make it so that we can import it into our master's hardware config so it knows what it's talking to. We'll hit Create and then Export. And I'll save this GSDML file to my desktop and close. Alright, now we can exit the hardware config and let's make a few changes to our project. The first thing is we'll go to our virtual master, and what we want to do is have this virtual master be able to accept an external master value. To do that, we'll go up to the synchronous operation object, right click, go to expert, and then say insert external master value. This window comes up, and if it doesn't, it can be found under the synchronous operation and under the external master value object and at the window configuration. What we'll do is we'll type in the input and output address as the same ones that we entered in the hardware config, which was 350 and 350. In this window, it doesn't ask us for the bytes because it is expecting that we're getting that motion profile that includes position, velocity, and acceleration, so it already knows that is 24 bytes. The second thing we need to do is go into our program and add some logic for when we want this to be in remote mode. The first thing we're going to do is really keep this the same. We're going to have the blue and the red axes gear on to the virtual master. So we can clean this up by cutting those out and then pasting them at the top, since both sides will utilize the same motion command. What we're going to add is another gear on command for our virtual master. We're going to pick our virtual master and we're going to give this virtual master its external master value. Alright, we'll just want to make sure that this is an absolute gear, which is this. Gearing takes place relative to axis 0. We'll also want to make sure that the synchronization is a time synchronized immediately. You may want to use a different synchronization method. This will just work best for this application. Next, and this is just for my code, I'm going to want to put a wait for condition, and that I don't want the code to execute any further unless I give it a reason to. So I'm going to wait until either my start command goes false or my remote master command goes false. Add a not there. Hit accept and OK. And that's because we don't want it to disable the axes unless we give it a reason to. We'll get rid of that placeholder. And that will just about do it. So let's go ahead and accept and compile. And we're going to add in one more program. In order for the slave to sync up to its master, we need to give it a sync on command, if you will. And that is handled as a startup task. So we're going to add one program in called startup. Hit OK. And I'm going to add in two things. I'm going to have a function call. And for now, I'll have a wait command. That'll set for 10 milliseconds. I'll explain that in a second. Let's go ahead and open up the function call. And in my command library, I'm looking for the following command: enable DP interface synchronization mode, which is right here under communication, interface handling, configuration, enable DP interface synchronization mode. I'll drag that on over, give it the dummy return value, and then the mode that I want will be automatic interface synchronization. I give it a 10 millisecond wait time for now, just to ensure that it will sync up before it actually begins any motion tasks. We can be a little bit more intelligent about this by having a wait for condition, and what we would be looking for is that our state of DP connection the state of DP interface synchronization is equal to DP interfaces synchronized. But for now, we'll just keep it as 10 milliseconds. I just wanted to put that in there just in case we have other things in the startup task, that this is a better method to go with. Go ahead and accept and compile. And in our execution system, I'll go ahead and throw in that newly created task into the startup routine. With that, we'll save and compile. And now we'll go online with our device. And we will download. And through the magic of video editing, we'll fast forward through all this so we can now focus on the master project. So now we'll open up the master's hardware config. And once that is loaded, we will do the same thing that we did for the slave. We'll want to ensure that there is a degree of uniqueness and how we configure this hardware. The first thing is making sure that the controller name is unique, which it currently is, as it ends in _master. Next, we'll want to go to our Profinet interface, which will be using the same X150 port. So we'll right click and go to Object Properties, and we'll make sure that this is unique by adding a -master. Next, we'll go to the IP address, which is the third thing that needs to be unique. And if you remember, we are using .2 for the slave, so we'll make this a .3 and hit OK. Next, we'll go to the Profinet tab, select 4 milliseconds to be consistent. We'll click on the iDevice tab, and we'll leave this as it is. Because this is a IRT master, it is not an iDevice. Next, we'll go to the Synchronization tab, and here is where we'll specify that it is a sync master. And we'll hit OK. Now, we'll right-click on that interface and select Insert Profinet IO System so we can bring in our GSD file. We do that by going to Options, Install GSD File, and then we'll go to our desktop and install it. And we'll just go ahead and hit OK through the messages and close. We find this file by going to Profinet IO, then Pre-configured Stations. We're using a D425 controller, and there it is, the PNIO-slave. So let's drag that over to our IO system. And at this point, let's see what happens if we do a consistency check. We get a message saying that the device, the PNIO slave, is in isochronous mode, but the device itself is not being operated in isochronous mode. This means that we need to specify that the relationship between what we did in the slave's hardware config and our current master hardware config, we need to specify that this is going to be in isochronous mode. We do this by clicking on the device, going to Interface, right-clicking, and hitting Object Properties. We'll jump over to the Synchronization tab, and just as we specified that was our sync master, here's where we'll specify that this is our sync slave. We click on IO cycle, and you may get this message saying, please check the consistency. What it's talking about is in isochronous mode, it defaults to nothing, so we need to change it to servo, which is the cycle clock that IRT operates off of. When we do that, you might notice that the cycle time is set to 1000 milliseconds, the default. So we'll need to make this 4 milliseconds as follows. We go to our Profinet interface, right-click, click on Domain Management, and set the send clock time to 4 milliseconds, and hit OK. Now, if we do a consistency check, we'll get another message, which is Topology Error. It says that a connection is not possible between the sync master and sync slave, which sounds worse than it actually is. All we have to do is go to the Profinet IO topology. When dealing with IRT, topology matters. This is how it calculates delay time between one device and another, and that information is critical when we're dealing with determinism. Once the topology editor opens, we'll go to Graphic View, and here is where we configure how we're laying out our system. I am going to connect port 1 of my master to port 1 of my slave, so I drag the two together, and I'll keep all the defaults and say OK. I also happen to be connecting my PC into port 3 of my master. Hit OK. And with that, I'll hit OK one more time. and say yes. We want to check one more thing, and that's with our Dynamics Integrated. Make sure that that is set at the 4 millisecond cycle time. We go to Object Properties, and then Isochronous Operation, and indeed it is at 4 milliseconds, so we're good there. With that, we'll save and compile, and we will go ahead and download. Next, we will exit, and we're just going to make one little change here to this program. So what I want is I want for my slave axes to follow the real axes on my master machine. So I'm not going to use the virtual master to give its current position value. I'm actually going to give the real axis because I want it to emulate what the real axes are doing on the master side. So I click on the real axis, then I right click, go to Expert, and then Insert External Synchronous Operation. Over here is where I'm going to use the input and output addresses as assigned in the hardware config. So I'm going to bring up the hardware config one more time. And when we click on our device, our slave device, we'll see that it added in for us the input and output at 260 and 260. This is opposed to the 350 that we set on the slave side, because when we load into the hardware config, it will automatically put it in the, let's say, the lowest available place. So, here on the master side, we're at 260 for input and output. So, over here, we'll use 260, 260. And again, we don't have to specify the byte length since Array knows I'm trying to send 24 bytes for the motion profile. Up here I have the option. I can send the set point of the axis, or I can send the actual value. So I can send what the motion controller is desiring the axis to do, or what it's actually doing. I'll go ahead and just set it to actual value, but for your machine you may want to pick set point just in case if there were a disturbance on the real axis, do you want that to be carried over into the slave axes? We'll go ahead and put on actual value for now. And that is all you have to do. Save and compile. And we'll go online. And we will download. And while that's going, I'll go ahead and connect my two controllers over Profinet. I'm going into port 1 for each of them. And let's just go ahead and clear all the faults here. Okay, good. So we can go ahead and go offline. And to demonstrate the rest, I will use the web server rather than having two projects open. And I get to my master device by typing in 192.168.0.3. And I'll go to my slave at 192.168.0.2. Alright, so let's go ahead and put them both into run by clicking settings and typing in our credentials. By default, the username and password are both Simotion. So let's put the master into run, and we'll do the same on the slave side. Put it into run. Okay, on the slave side, we'll go ahead and start its routine. So we go into a watch table. I'm going to click on Simotion to access my Simotion data. Then I'll go to Unit to access my program data. Here's my slave routine, and here are the variables. We'll use our start command, our remote master command, and the speed command. So I'll go ahead and enable my axes, and I'll give them a speed for now. Okay, now let's go into the master side. Go into the watch table, Simotion, unit, and here's my master routine. I'll bring in the start and the local speed. We'll go ahead and enable those axes and give them a speed. And now let's see what happens when we go into remote master mode by setting this bit to true. So as you can see, when we switch into remote mode, the axes from our slave project follow the axes from our master project. And when I toggle the remote master bit off, we can see that the slave axes go back to their original routine. So let's go ahead and put it back into remote mode. So in summary, we were able to link together two separate projects without the need for rebuilding our project from scratch or sharing any code. I hope that you found this video informative. Again, my name is Matthew Purse for Siemens Motion Control. If you have any questions about what we covered here, you may contact me at matthew.purse@siemens.com. Thanks for watching.